Imagine leaving everything you have ever known behind, stepping into an endless, freezing abyss where help will never arrive. The planet we call home becomes nothing more than a tiny, glittering speck of dust, easily hidden behind the tip of your thumb. You are moving into the deep, dark outer edge of our solar system, an unforgiving frontier where the sun is just a cold, distant star in the sky. Out here, the rules of human survival no longer apply, and a single mistake means you are lost in the cosmic dark forever. This is not a gentle journey of discovery, it is a one-way descent into the most isolated territory in existence. This is the reality of travelling to the absolute edge of our sun's family of planets. We often look at diagrams of our solar system in textbooks and see a neat, crowded neighbourhood of worlds sitting comfortably next to each other. These drawings are completely wrong and give us a false sense of security about the structure of space. In reality, the true scale of our cosmic backyard is mind-bogglingly vast and mostly empty. If you were to look at a genuinely accurate map, the planets would be completely invisible. Microscopic dots separated by thousands of miles of utter nothingness. The inner solar system, where Earth resides, is relatively cosy and compact compared to what lies beyond. Once you cross the threshold of the asteroid belt, the gaps between worlds expand exponentially, turning a journey across space into an endurance test of cosmic proportions. To understand how far away these outer worlds really are, we have to rethink our basic understanding of distance. When we talk about travelling to the outer gas giants and ice giants, we are talking about distances that take years, even decades, to cross with our fastest technology. The void is so immensely wide that human minds struggle to comprehend the sheer scale of the separation. It is a lopsided universe where the vast majority of the physical space is concentrated in the dark, frozen outer reaches. As we push past the orbit of Mars, the warmth of our star begins to fade rapidly, and the true isolating nature of the cosmos reveals itself. The primary target of our deep space analysis is Neptune, the eighth and most distant official planet from our Sun, a world wrapped in deep blue clouds and violent screaming winds. It sits at the very edge of the classic solar system, acting as a giant frozen sentinel before the open wilderness of interstellar space. Neptune is not just far, it is conceptually isolated from the rest of the planetary family. The sheer chasm of space that surrounds this ice giant is enough to make any space traveller realise just how fragile and lonely human existence truly is. It represents the ultimate boundary line for our current ambitions of space exploration. Orbiting this distant blue world is Triton, a moon that shouldn't be where it is, behaving in a way that defies the standard rules of how moons are supposed to act. Triton is a captured world, a cosmic hitchhiker trapped by Neptune's massive gravitational pull long after the solar system was formed. It spins backward against the rotation of its parent planet, a permanent rebel in a dark sky, locked in a slow, tragic death spiral. This strange, icy moon is covered in frozen nitrogen and active geysers, making it one of the most hostile yet fascinating targets for scientific study. Together, Neptune and Triton form a bizarre, isolated system that challenges everything we know about planetary formation and orbital mechanics. To truly comprehend the violent nature of these distant worlds, we must examine their extreme atmospheric conditions. Neptune is home to the most ferocious weather in the entire solar system, with winds that blow at supersonic speeds faster than the speed of sound on Earth. These are not mere storms, they are planetary convulsions that rip through the hydrogen and helium atmosphere, driven by an internal heat source that scientists still do not fully understand. The cold out there is unimaginable, dropping to temperatures where gases freeze solid, yet the energy driving these winds is absolutely terrifying. It is a world of pure dynamic chaos wrapped in a calm, beautiful shade of azure blue. Deep beneath those beautiful, violent blue clouds lies an exotic interior that sounds like something out of science fiction. The immense pressure and temperature inside Neptune compress materials into states that cannot naturally exist on Earth. Scientists hypothesize that deep within the mantle of the ice giant, it literally rains diamonds. With vast oceans of liquid carbon containing floating bergs of solid diamond. The chemical makeup is a strange mix of water, ammonia and methane ices subjected to forces so intense that the molecules break apart and behave in entirely alien ways. This is a place where the very definition of rock, water and air becomes blurred under the crushing weight of a giant world. Reaching a destination so incredibly far away requires an understanding of orbital mechanics that strains the limits of human ingenuity. You cannot simply point a rocket at a planet and fire the engines. The fuel requirements would be completely impossible for any machine we can build. Instead, space agencies must rely on the delicate celestial dance of gravitational assists, using the gravity of inner planets like pillows to fling spacecraft across the void. Every single mission to the outer solar system is a masterclass in cosmic geometry, requiring precise calculations where a mistake of a fraction of a degree can throw a spacecraft millions of miles off course, leaving it to drift endlessly into the dark. Our historical blueprint for exploring this deep frontier is the legendary Voyager 2 mission, which gave humanity its very first close-up look at these distant realms. Launched in the late 20th century, this small robotic explorer utilised a rare alignment of the outer planets to pull off a grand tour of the outer solar system. When it finally reached Neptune, it sent back pictures that shocked the world, revealing a vibrant, active planet instead of a dead, frozen ball. The data gathered by Voyager 2 remains our most valuable treasure trove of information about the edge of our solar system, serving as the foundation for all future mission planning. If humanity ever decides to send a crewed mission to these distant worlds, the physical, biological and psychological challenges will be completely unprecedented. A journey to Neptune and Triton would not be a matter of months, but a multi-year expedition into total isolation. The human body is built for Earth, and living in microgravity for years on end causes bones to dissolve, muscles to wither, and radiation to mutate cells. Even more terrifying is the psychological toll of looking out the window and seeing Earth disappear into a microscopic dot, knowing that if anything goes wrong, you're entirely on your own. The communication lag alone would create a terrifying sense of exile for any human crew brave enough to make the journey. At the distance of Neptune, radio signals travelling at the absolute speed of light take over 4 hours to travel just one way. If an astronaut says hello, they must wait nearly 9 hours to hear a response from mission control back on Earth. This means that in the event of an emergency, the crew cannot rely on real-time advice or help from home. They must be completely self-sufficient, making life or death decisions in a vacuum of isolation. The speed of light, which feels so instantaneous on Earth, becomes a cruel, mocking barrier that permanently detaches explorers from human society. The sheer scale of this isolation cannot be overstated, as the distance creates a profound disconnect from the rhythms of terrestrial life. On Earth, our lives are dictated by the predictable cycle of day and night, the changing of seasons, and the comforting presence of a thick, protective atmosphere. Out past the asteroid belt, all of those constants vanish entirely. The sun shrinks until it provides no meaningful warmth, appearing only as an exceptionally bright dot in a permanent star-speckled midnight. For a human crew, This environment would feel like living inside a sensory deprivation chamber of cosmic proportions, challenging the very limits of sanity. To successfully navigate this terrifyingly vast distance, a spacecraft must be designed as a completely closed, perfect ecosystem capable of sustaining life for years without restocking. Every drop of water must be recycled infinitely, every breath of air scrubbed of toxins and reused, and every calorie of food carefully accounted for and grown in specialised hydroponic bays. There is absolutely no room for mechanical failure or biological contamination. A single leak, a single crop failure, or a single malfunctioning valve means a slow and agonising death for everyone on board. The ship becomes a literal life raft floating on a vast, indifferent ocean of vacuum. Furthermore, the threat of deep space radiation poses a constant, invisible danger to any long-duration mission. Outside the protective magnetic shield of the Earth, the solar system is flooded with high-energy cosmic rays and solar particles that pierce through metal and human flesh alike. Over a multi-year journey to the outer planets, this radiation exposure dramatically increases the risk of fatal cancers, cognitive decline, and acute radiation sickness. Shielding a spacecraft against these energetic particles requires massive amounts of heavy material or advanced magnetic fields, adding immense weight to an already overburdened vehicle design. The journey past the gas giants like Jupiter and Saturn reveals just how much the environment changes as you head deeper into the dark. Jupiter is a massive, roaring furnace of radiation and gravity, a system so large it acts like a miniature solar system of its own. Saturn follows with its stunning, complex ring system, a beautiful monument to cosmic destruction and orbital resonance. But once you pass Saturn, you enter the true wilderness, leaving behind the worlds that are relatively easy to observe from Earth and entering the realm of the icy outcasts, where the shadows grow incredibly long and the cold deepens significantly. It is in this outer realm that we find Uranus, the tilted misfit of the solar system, rolling on its side as it orbits the Sun. Uranus and Neptune are categorized together as ice giants, distinct from the gas giants because their composition is dominated by heavier elements like oxygen, nitrogen, and carbon rather than just hydrogen and helium. These worlds are fundamentally different from Jupiter and Saturn, representing a completely unique class of planetary bodies. The transition from the gas giants to the ice giants marks a significant shift in the chemistry and history of our solar system, offering clues to how our cosmic home was built. As we focus our attention back on Neptune, we must realise that studying this world is like looking into a time capsule from the early days of planetary formation. The materials found in the outer solar system have remained relatively undisturbed by the intense heat and solar wind of the Sun for billions of years. By analysing the composition of Neptune's atmosphere and the structure of its deep interior, scientists can piece together the conditions that existed when the planets were first condensing out of the primordial nebula. It is a key that unlocks the history of our origin, hidden in the coldest depths of space. The planet's vivid blue coloration is primarily caused by the presence of methane in its outer atmosphere, which absorbs red light from the Sun and reflects the blue wavelengths back out into the cosmos. However, there is still an unresolved scientific mystery regarding the exact shade of Neptune's blue, as it is noticeably deeper and richer than the pale, hazy blue of Uranus. This suggests there is an additional unknown chemical component or atmospheric layer that alters the light, a hidden ingredient that continues to elude our best observations and theoretical models. The violent weather patterns observed on Neptune are a major point of confusion for planetary scientists, as the planet receives only a tiny fraction of the sunlight that Earth does. On Earth, weather is driven entirely by solar energy heating the atmosphere and oceans, creating winds and storms. Yet, Neptune, despite being 30 times further from the Sun than Earth, exhibits winds that are far more intense than any storm ever recorded on our home planet. This proves that the driving force behind Neptune's terrifying weather is internal, powered by heat left over from its formation or generated by ongoing gravitational contraction deep inside its core. This internal heat engine causes massive storm systems to rise from the deep interior, breaking through the upper cloud decks and creating visible features like the Great Dark Spot, a massive storm system large enough to swallow the entire Earth. Discovered by Voyager 2, this colossal vortex behaved similarly to Jupiter's Great Red Spot, but proved to be far more unstable, completely vanishing and being replaced by new storms over the span of just a few years. This rapid transformation shows that despite its frozen exterior, Neptune is a dynamic, ever-changing world of intense energy and atmospheric violence. The incredible constraint of light travel time is far more than a simple quirk of astronomy. It serves as the foundational root of practically every technical, psychological and medical obstacle a human crew would have to confront while stationed at Neptune. This is because the speed of light dictates the absolute parameters of communication across the void. The radio signals that space agencies use to manage, track and interact with every single spacecraft in our fleet do not travel instantaneously, they move at exactly the speed of light through the vacuum. When you send a transmission from the surface of the Earth to a vehicle parked in orbit around Neptune, that data requires more than 4 full hours just to arrive at its destination. If the crew immediately broadcasts a confirmation or a reply, that signal requires another 4 hours to make the journey back home. Consequently, a single basic interaction asking one question and receiving one response takes more than 8 hours of real-time waiting. This dynamic completely eliminates the possibility of a normal. It removes any sense of immediate connection or shared presence between the explorers and the ground. To put this into perspective, think about the current standard for human spaceflight on the International Space Station, where astronauts routinely participate in live video calls with their families and mission controllers with a delay of less than a second. Even during the historic Apollo lunar landings, which took place 250,000 miles away, the astronauts experienced a one-way delay of only about 1.3 seconds, meaning a complete round-trip exchange took roughly 2.5 seconds. When you calculate the communication lag at Neptune, you realise that the one-way delay by itself is approximately 11, 0.0 times longer than what the Apollo crews dealt with during their voyages to the Moon. The deep ramifications of this massive operational gap become staggeringly clear when you consider how emergencies are managed, but for now it is vital to grasp the core truth. Neptune is located so deep in the abyss that the very physics of light speed becomes an unyielding prison wall, separating a human crew from every familiar element of their home world. Furthermore, analysing this extreme distance does not simply highlight how existing space travel difficulties scale up, it exposes a structural truth about our solar system that standard educational illustrations completely obscure. The arrangement of worlds orbiting our Sun is not a uniform, step-by-step ladder. Instead, the architecture of our solar system is violently lopsided, bunched up tightly at the centre and incredibly hollow at the edges. The inner terrestrial worlds Mercury, Venus, Earth and Mars are practically crowded together, all residing within a compact zone that spans roughly 1.5 astronomical units from one another. This is the relatively warm, solid and sunlit domain where the entirety of human history, evolution and exploration has played out. Mars, which represents the absolute farthest frontier that any modern space agency has ever actively planned to send a human crew, rests at an average distance of about 1.5 astronomical units from the central star. On a classic schoolhouse wall map, Mars looks like it is positioned at a reasonable remove from Earth, and when you look at the total scale of the solar system, it genuinely is. Once you venture past Mars, however, you cross the wide expanse of the main asteroid belt and reach Jupiter, which orbits at roughly 5.2 astronomical units from the Sun. In making this single leap from the terrestrial zone to the first gas giant, you have more than tripled the total distance from the Earth to Mars. The spacing continues to expand dramatically as you move outward. Saturn sits at approximately 5 astronomical units, and Uranus is located far beyond that at roughly 19 astronomical units. Then, after traversing those immense distances, you must cross another 11 astronomical units of absolute, howling nothingness to finally reach Neptune at its orbit of 30 astronomical units. This particular geometric fact demands careful contemplation because it is incredibly easy to overlook on a map, yet it is absolutely central to understanding the true isolation of the outer system. The empty gap separating Uranus from Neptune is roughly 11 astronomical units wide, meaning that this single pocket of vacant space is larger than the entire distance from the centre of the Sun all the way out to the orbit of Saturn. The outermost boundary of our planetary neighbourhood holds far more raw empty vacuum than the entire inner and middle solar system combined. Neptune does not sit at the end of a continuous line of planets, it exists far across an enormous cosmic chasm. Confronting this chasm is not merely a test of endurance or patience for an exploration team. It represents a massive, multifaceted crisis of physics, engineering, biology, and psychology happening all at once. Every single hurdle that a deep space vessel must successfully manage, including fuel storage, food preservation, radiation protection, mechanical maintenance, communication systems, and biological stability, grows drastically worse as a direct function of distance and duration. By the time you extend these calculations to the orbit of Neptune, both the distance parameters and the time requirements scale up to values that completely break the limits of any technology currently operational or even under active development by modern engineering teams. To fully comprehend what it takes to cover this gap, we must look at the historical precedent of the only robotic explorer that has ever successfully crossed it. Voyager 2 began its journey from the launch pads of Cape Canaveral on August 20, 1977. It is crucial to remember that the probe did not and could not take a straight path to its final destination. If engineers had attempted to fire a spacecraft directly from Earth to Neptune using traditional chemical rocket propulsion, the transit alone would have required roughly 3 decades of coasting through the dark. Instead, the mission took advantage of a highly unusual, once-in-a-lifetime planetary alignment that occurred in the late 20th century. This precise arrangement of worlds gave Voyager 2 the rare opportunity to perform a succession of gravity assists, swinging closely past Jupiter, Saturn, and Uranus. The probe used the massive gravitational fields of each of these giant planets to accelerate its speed and dynamically reshape its flight path. Every single planetary encounter acted as a cosmic slingshot, boosting the spacecraft's velocity without requiring it to ignite its onboard engines or expend a single gram of precious propellant. It was an absolute triumph of orbital navigation, a complex celestial billiard shot that relied on planetary positions that will not repeat themselves until the 22nd century. Yet, even with the immense speed advantages gained from this grand tour of gravity assists, the journey across the outer solar system still required 12 years of continuous travel. Voyager 2 finally completed its approach to Neptune on August 25, 1989, hurtling through the system at a staggering velocity of approximately 19 kilometers per second, which translates to roughly 42,000 miles per hour. As it swept past, the probe cruised a mere 3,000 miles above Neptune's North Pole, collecting the very first, and to this day, the only close-up photographs and scientific readings of this distant world and its family of moons. If you factor in the long approach and departure tracking phases, the broader encounter spanned several months, but the actual window of close proximity lasted for only a few brief hours. This is the brutal balance of deep space exploration, 12 long years of monotonous, silent transit through the dark, all for a handful of hours spent in close contact with the outermost planet. The reality that Voyager 2 uncovered during those brief hours demonstrated precisely how alien, cold, and visually surreal the outer solar system truly is. This alien nature manifests not only in the complex data points of planetary physics, but in the basic, fundamental sensory experiences of light and sight. The severe lack of ambient sunlight at 30 astronomical units created an extraordinary, unprecedented technical hurdle for the imaging scientists managing the vehicle's cameras from Earth. When the spacecraft had explored Jupiter, it operated within an environment with abundant, bright solar illumination, making planetary photography relatively simple and clear. As it pushed onward to Saturn, the light dimmed noticeably, but it remained entirely manageable for the onboard instruments. By the time Voyager 2 reached Uranus, however, the dwindling sunlight began to introduce major complication. The photographs returned from that encounter possessed a distinct, hazy and washed-out look that left many researchers frustrated. When the vehicle finally arrived at Neptune, the lighting conditions crossed into a critical threshold. The target world was illuminated so poorly that Voyager 2's older camera systems absolutely required extended exposure times to gather enough photons for a usable picture. But because the probe was screaming past the planet at tens of thousands of miles per hour, any camera exposure long enough to gather sufficient light would naturally cause the resulting image to smear into a useless, blurry mess. To bypass this physical conflict, flight engineers had to completely reprogram the spacecraft's attitude control software mid-flight, instructing the entire vehicle to slowly rotate on its axis during each exposure. This delicate maneuver perfectly counteracted the probe's forward momentum, steadying the camera lens against the dimly lit atmosphere below and allowing humanity to see Neptune clearly for the first time. This profound darkness is the defining characteristic of the environment, a consequence of how drastically sunlight diminishes as you move away from the centre of the solar system. Because light spreads out in all directions as it travels through space, its intensity drops according to the inverse square law. At 30 times the distance from the Sun compared to Earth, the sunlight reaching Neptune is not just 30 times dimmer, it is 30 squared, or 900 times less intense than what the Sun would look nothing like the brilliant warm orb we see in our skies. It would shrink down into an intensely sharp, piercing needle of white light, completely lacking any palpable warmth, looking more like an exceptionally bright star than a life-giving sun. The sky around it would remain a permanent deep black, and the illumination cast over the blue cloud decks of Neptune would feel like a perpetual twilight, a cold and eerie dimness that never brightens. This dim, frozen environment serves as the final gravitational anchor of our planetary neighbourhood, marking the boundary line where the organised solar system begins to dissolve into the scattered icy debris of the Kuiper Belt and the open expanse of the interstellar void. Successfully guiding a robotic probe to this remote domain stands as a monumental multi-generational achievement of robotic engineering. But attempting to transport a living, breathing human crew across that same distance introduces an entirely different category of problem. It is a human venture that forces us to completely re-evaluate not just the absolute limitations of our machinery, but the strict constraints of our biology, the vulnerabilities of our psychology, and our most fundamental assumptions about what it actually means to detach from home while trying to remain tethered to it. Distance, when written on a chalkboard or a digital, is nothing more than an abstract number. The true significance of that number lies in what it physically does to every single life support mechanism, communication line, energy source, and psychological anchor that a human being relies on to stay alive and sane. It tests the quiet, terrifying reality of whether anyone back on Earth is truly capable of listening or helping when you are that far away. Every single astronaut who has ever left the ground and lived in the vacuum of space has relied on one specific invisible lifeline more than any other resource. It is not oxygen, though a constant supply of breathable air is obviously mandatory for survival. It is not water, though hydration is entirely essential to keep the human body functioning. The true vital lifeline that holds human psychology together and prevents a crew from breaking across the void is reliable communication. It is the basic, profound ability to hear a familiar, comforting voice from home. It is the capacity to broadcast a complex question and receive a helpful, immediate answer from a team of experts. It is the security of knowing that if a system fails or an anomaly occurs, you can speak into a microphone, say that something is wrong, and instantly hear a specialist say, "We see it, and here is exactly how you fix." Every crewed mission launched in the history of our species has operated strictly within this protective pocket of real-time contact. From Yuri Gagarin's singular groundbreaking orbit in 1961 to the decades of continuous human habitation aboard the International Space Station, astronauts have always existed in a spaceflight environment where the Earth was, for all practical purposes, right there beside them. Home has always been present, immediate, and completely reachable. But at the distance of Neptune, that essential psychological and operational lifeline does not merely weaken under the strain. It does not simply fray at the edges, it shatters into absolute pieces. To understand the weight of why this occurs, you must first appreciate just how deeply modern spaceflight depends on this instantaneous connection with the ground. When astronauts are stationed on the International Space Station, they are never truly isolated from human society. They maintain a nearly seamless, unbroken line of communication with multiple mission control installations scattered across the globe, from Houston to Moscow. The communication lag is so tiny that it is practically unnoticeable, a mere fraction of a second that makes any transmission indistinguishable from a standard terrestrial phone call. If a piece of life support equipment undergoes a sudden malfunction, ground controllers receive the exact same telemetry data on their screens at the same moment the crew notices it. They can diagnose the root cause of the failure in real time, consult with design engineers, and talk the astronaut through the repair procedure step by simple step. If a serious medical emergency occurs in orbit, flight surgeons on Earth can watch the patient through live high-definition video feeds, ask the crew questions, get immediate feedback, and actively guide a medical procedure as it unfolds. Even when an astronaut experiences severe psychological strain, battling the creeping onset of anxiety, chronic insomnia, friction with crewmates, or the slow. Exhausting wear and tear on morale that inevitably accompanies months of physical confinement, the remedy is readily available. They can easily arrange a private, real-time video session with a clinical psychologist on the ground who listens and responds to their words the very moment they are spoken. This massive support network is not a secondary luxury or a minor comfort added to space missions. It is the core functional reason why long-duration human spaceflight is even possible. Space agencies like NASA have spent decades studying this dependency with immense care. They recognise a fundamental truth: astronauts are not completely independent, self-contained units who can operate flawlessly in a vacuum. They are vulnerable human beings who remain deeply embedded in a complex, real-time web of social and technical support that spans from the orbital module all the way down to the conference rooms, engineering labs, and offices on Earth. If you completely sever that web, you dismantle the entire underlying system that keeps a human being functional, safe, and psychologically stable in the most unforgiving and hostile environment our species has ever tried to occupy. Now imagine what happens to this entire dynamic the moment you introduce a severe communication delay. Even for a mission to Mars, which is vastly closer than the outer planets, NASA engineers are already deeply terrified by the communication barriers that a crew would face. Because the distance between Earth and Mars changes constantly based on their respective positions in their orbits around the Sun, the one-way light travel time varies from a relatively manageable 3 minutes at its absolute closest alignment to roughly 22 minutes at its farthest separation. This means that a standard round-trip exchange sending a distress message and waiting to receive an answer could consume anywhere from 6 minutes to nearly 3/4 of an hour, depending on where the two planets happen to be in their orbital dance. This is not a distant academic worry, it represents one of the most significant unresolved operational hurdles for future Martian exploration. But when you transport that same scenario out to the ice giant Neptune, the scale of the problem expands beyond recognition. The one-way delay stabilises at more than 4 full hours, ensuring that any cry for help or request for guidance must drift through billions of miles of vacuum for half a standard workday before anyone on Earth even registers that a message was sent. If a critical system on a Neptune-bound vehicle begins to fail, such as a slow leak in the atmospheric shielding, a sudden pressure drop in the fuel arrays, or a software glitch in the primary navigation computer, the crew cannot rely on mission control to save them. By the time the telemetry data showing the initial malfunction arrives on a controller's monitor in Houston, 4 hours have already passed since the event occurred. By the time the ground team analyses the data, formulates a fix, and broadcasts the instructions back to the ship, another 4 hours elapse. A total of 8 hours will have passed from the initial moment of failure before the crew receives a single line of advice. In a high-stakes emergency where survival is measured in minutes or seconds, an 8-hour delay means that help from Earth will always arrive far too late. The explorers are completely, terrifyingly on their own, forced to act as their own engineers, flight controllers, and technicians without any safety net. This unprecedented level of isolation completely transforms the psychological reality of the voyage, severing the crew from the shared temporal existence that defines human life. When you are separated from home by a 4-hour communication lag, you no longer inhabit the same present moment as the rest of humanity. You exist in an entirely separate time frame. Every transmission you receive from Earth is a literal echo from the past, describing events that occurred hours ago and have already been catalogued into history by the time you hear about them. Every word you speak into your recorder is a message sent into the future, destined to be heard by people who have already moved hours past the moment in which you spoke. Nothing is simultaneous, nothing is current. The comforting immediacy of human interaction is replaced by a profound, haunting silence that underscores just how far you have wandered from the cradle of civilization. The deep psychological deterioration that stems from this communicative breakdown is completely decimated by the time delay. Investigational studies carried out in NASA's highly controlled analog environments have conclusively demonstrated that an individual's perceived level of social support diminishes in a highly measurable, steady decline over extended periods of isolated confinement. Even in scenarios where communication channels with the outside world remain technically functional and open, crew members who participated in long-duration HERA campaigns, where operational engineers deliberately introduced realistic communication lag profiles, documented a profound shift in their psychological state. They reported feeling significantly less emotionally connected to the staff working at mission control, feeling drastically less supported or sustained by external networks, and experiencing a sharp, forced transition toward relying almost exclusively on their immediate fellow crew members for any form of basic emotional sustenance or mental validation. It is vital to recognise that these concerning psychological findings did not emerge from grand, multi-year voyages into the outer dark. They emerged from controlled simulated campaigns that lasted for a mere 45 days, involving communication delays that were measured in only a few brief minutes. If a delay of just 5 or 10 minutes can systematically erode an astronaut's sense of connection to Earth over the span of a single month, the psychological impact of a 4-hour communication delay over a multi-year timeline becomes a completely unparalleled mental health crisis. At Neptune, the unyielding physics of light speed does not simply delay operational data. It systematically starves the human mind of its foundational social anchoring, trapping a tiny group of explorers in a profound interpersonal vacuum where Earth is reduced to a silent observer from a distant past. This severe state of communicative exile completely reshapes how a crew experiences the passage of time and the preservation of memory. Every historical human explorer who has ever crossed the boundary of civilization retained a vital sensory anchor that connected them directly to the world they left behind. Master mariners navigating the trackless expanses of the open ocean could look up at the horizon and see the exact same sun rising, and watch the exact same constellations tracking across the night sky that illuminated their home ports of departure. Brave scientific researchers overwintering in the frozen dark wilderness of the Antarctic continent could step outside their research modules and look at the same moon that was rising over the roofs of their families' houses thousands of miles away. Even the legendary Apollo astronauts, who pushed the boundaries of human travel farther than anyone else in history, could turn their heads, look out the thick quartz windows of their command module, and see the Earth hanging in the deep black sky. It appeared to them as an enormous, brilliantly luminous, heartbreakingly beautiful marble of blue, white and green, floating close enough that its swirling weather patterns and continents were perfectly visible to the naked eye. They were close enough that an astronaut could physically point out the window and locate the exact geographical city where their children were sleeping at that very moment. A crew stationed at the ice giant Neptune possesses absolutely none of these comforting sensory or visual connections. For these outer explorers, the Earth has completely vanished from the sky, shrinking down so far past the resolving capabilities of the human eye that it cannot be found without the aid of a powerful, precisely targeted telescope. The Sun, the great life-giving engine of our solar neighbourhood, has lost its majestic presence and shrunk down to a single, intensely bright, cold point of light in a permanent midnight sky. Strangely, the constellations that surround the ship appear essentially unchanged from how they look from an open field on Earth. The stars themselves are located at such unimaginable interstellar distances that shifting your physical position by 3 billion miles across the solar system alters their perspective by an imperceptible degree. This specific astronomical reality creates a deeply disorienting psychological paradox for the crew. They find themselves inhabiting a night sky that looks almost completely identical to the one they grew up looking at from their backyards, yet it is entirely stripped of the one specific celestial object that made that sky feel like it belonged to humanity, the vital emotional anchor, the immediate visual proof that their home world actually exists and is waiting for them, has been completely erased from their daily conscious experience. They can no longer glance out of a spacecraft observation window to find quick psychological reassurance or comfort. They cannot pick up a handheld camera, snap a quick photo of their home planet, and send it back to their loved ones as a token of shared presence. The world they originated from has systematically transitioned from a solid, tangible reality into a pure cold abstraction. It is reduced to nothing more than a set of coordinate numbers flashing on a navigation screen, a microscopic blue dot hidden within the digital field of view of an external star tracker, and a collection of personal memories that inevitably grow older, fuzzier, and less vivid with every single passing year of the mission. This total visual severing is not an abstract or minor psychological footnote in a mission plan. It represents a massive, ongoing biological strain on the human psyche. Behavioral psychologists at NASA have consistently emphasized that Earth observation, the simple, regular practice of looking down at our planet through a spacecraft window, stands as one of the single most powerful, effective psychological countermeasures available to combat the intense emotional toll of long-duration spaceflight. Astronauts living on the International Space Station routinely describe the act of looking at Earth as a deeply restorative, almost spiritual experience that keeps them grounded. The sight of the massive blue oceans, the complex swirling lines of white clouds, the deep greens of the continents, and the thin, incredibly bright neon line of the protective atmosphere provides a visceral, immediate reminder that the vibrant world they belong to is right there, travelling right along with them, waiting for their eventual return. Many orbital explorers have explicitly noted that photographing the Earth was their absolute most valued and essential recreational activity during their time in orbit. It is a daily behavioural practice that simultaneously fights off the crushing monotony of life inside a metal hull, strongly reinforces their personal connection to human society, and generates that profound, transformative emotional state known across behavioural science as the overview effect. When you travel out to Neptune, the overview effect is completely obliterated from existence. There is no vibrant, living planet to look at, no homeworld spinning comfortably below the ship's keel. There is only a massive, alien, dark blue ball of gas and ice, a captured moon erupting with freezing nitrogen geysers, and a sun that has been mocked and downgraded into a simple star. Perhaps the most profoundly disorienting and unsettling aspect of this entire environment is the severe temporal displacement that the 4-hour communication delay continuously inflicts upon the consciousness of the crew. When an astronaut living on the International Space Station sends a digital message or makes a video call to their family, the response arrives back almost instantaneously. Their interaction exists entirely within a shared mutual time frame. Both participants in that conversation inhabit the exact same present moment. At the distance of Neptune, however, the human crew lives in an entirely separate, isolated, temporal reality from the civilization they left behind on Earth. Any transmission broadcast from the high-gain dish of a vehicle orbiting Neptune is already a literal piece of history, a dispatch from the distant past by the very moment it finally washes over the receiver antennas on Earth 4 hours later. Conversely, any reply formulated and broadcast by mission control is already an outdated artifact from the past by the time it travels through the 3 billion mile void and reaches the ears of the crew. Absolutely nothing is simultaneous, nothing is current. Every single piece of human interaction is severely delayed, completely outdated, and emotionally stale before it can be processed. Consider the human weight of this temporal dislocation when applied to the standard milestones of human life. A crew member's child could be born back on Earth, and the parent stationed at Neptune would remain completely ignorant of the child's entry into the world for 4 full hours after the delivery was complete. If that parent immediately records a joyful, tearful message of congratulations and broadcasts it back down the line, that transmission requires another 4 hours to make the inbound journey. The child would be nearly a full day old 8 hours into its independent life before a single basic exchange of greeting could be completed between the two worlds. In a darker scenario, a crew member's parent could suffer a sudden medical emergency and pass away on Earth. The tragic news would have to crawl silently through the cosmic vacuum for 4 hours before it could reach the grieving child orbiting the ice giant. The child's immediate outburst of grief, their desperate words of remembrance, and their profound psychological need for familial comfort would radiate outward from Neptune at the absolute speed limit of physics, only to arrive back at a world where the funeral has already completely concluded. They would receive the message at a time when the other mourners have already packed up their things, left the cemetery, and gone back to their quiet homes. The profound moment of shared human grief will have completely passed by, leaving the isolated explorer to mourn in a permanent state of temporal exile. These are not wild hypothetical scenarios cooked up for dramatic effect. These are the precise, inevitable life events that naturally occur over the multi-year and multi-decadal timelines required for deep space exploration. A realistic mission to Neptune, demanding an absolute minimum of 12 years of continuous travel just to arrive at the destination, would easily encompass an entire generation of human events. Over those long years, the fabric of life on Earth would continue to weave itself completely independent of the crew. Children would be born, elderly family members would pass away, marriages would be celebrated, divorces would dissolve partnerships, sudden illnesses would strike, and miraculous recoveries would occur. Entire nations would hold major elections, devastating wars would break out and reach peace treaties, natural disasters would reshape coastlines, and massive technological revolutions would fundamentally alter terrestrial society. The crew would be forced to process the entire history of their species through the filter of a mandatory 8-hour round trip delay. They would learn about radical, sweeping changes in the structure of the world they left behind only after those massive events had already solidified into dry history lessons. They would find themselves recording emotional responses to profound joys and deep sorrows that had already completely faded away into the routine of daily life on Earth by the time their words finally arrived. As the months and years of this severe temporal dislocation slowly stack up, a profound transformation occurs within the psychological structure of the crew's minds. Earth slowly but surely ceases to exist in their consciousness as an active, living place that is happening right now. Instead, it morphs into a mythic place that exists strictly in the past tense. Every single packet of data, news brief, or personal letter that arrives from the inner solar system comes stamped with an unyielding digital disclaimer. This event occurred 4 hours ago. Every single outbound thought or status report transmitted by the crew carries the exact same historical limitation. The two separate worlds, the tiny artificial habitat struggling to survive in the freezing orbit of Neptune, and the massive ancient civilization thriving back on Earth, begin to drift apart along an invisible axis. They do not just separate across physical space, they drift apart temporally, emotionally, and experientially. The explorers certainly remain intellectually aware that the planet Earth is out there in the dark. They can still routinely download extensive data files, major world news updates, and digital entertainment packages broadcast across the vast distance. But the Earth they are interacting with is always a ghost world. It is a delayed Earth, a stale Earth, an Earth that has already moved completely past the very moments and descriptions they are currently watching on their screens. This is the true hidden horror of what 4 hours of absolute signal silence actually means. It is far more than a minor engineering bottleneck that makes communication slow. It is a systematic, quiet severing of a human being's membership in the present tense of human history. This isolation from the human timeline is further complicated by the fact that the crew must manage a machine that is completely detached from any possibility of mechanical or logistical support from home. To keep a small group of human beings alive in an environment where temperatures hover near absolute zero requires an engineering infrastructure of flawless reliability. Every single system on board the spacecraft, the carbon dioxide scrubbers, the water reclamation loops, the agricultural lighting grids, the primary nuclear reactors, and the deep space communication transmitters must operate continuously for 15 or 20 years without a single catastrophic failure. When we look at our current crown jewel of long-duration spaceflight, the International Space Station, we see a vehicle that has been continuously occupied by human crews since the absolute turn of the millennium. Yet, the space station is entirely incapable of surviving on its own. It exists within a massive, highly fragile umbilical network of constant cargo resupply launches, regular technical maintenance, upgrades, and a permanent dedicated ground support structure consisting of thousands of elite engineers who monitor its complex systems every second of every day around the clock. If a major component fails on the station, a replacement part can be tucked into the nose of a commercial rocket and delivered to the crew within a matter of days or weeks. A spacecraft drifting in the dark blue shadow of Neptune has no such safety net. It must achieve that same god-like level of operational reliability with absolutely zero resupply missions, zero physical maintenance interventions from ground technicians, and a tiny, isolated crew of fewer than 10 individuals. This handful of explorers cannot afford to be simple specialised pilots or focused scientists. They must simultaneously act as elite researchers, master nuclear engineers, emergency physicians, hydroponic farmers, deep space plumbers, industrial electricians, and clinical psychologists, all at the exact same time. They must carry the entire intellectual weight of an industrial civilization within the tight confines of their shared living module, knowing that if any single one of them fails to master their craft, the entire mission collapses into a frozen tomb. This grim reality directly introduces the one defining operational characteristic that separates a voyage to Neptune from any other exploratory campaign ever attempted by the human species: the absolute mathematical impossibility of rescue or abort. If a catastrophic failure occurs aboard the International Space Station, such as a sudden hull depressurization event caused by a micrometeoroid impact, an uncontrollable electrical fire in an instrument rack, or a severe collision with a piece of orbiting space junk, the crew has an immediate, guaranteed exit strategy. They can instantly scramble into their permanently docked capsule vehicles, initiate emergency separation protocols, and drop back down through the thick blanket of the atmosphere to safety on the Earth's surface within a matter of a few brief hours. This is not an idealistic or abstract contingency plan written in a dusty manual. It is a living, breathing operational protocol that space agencies have been forced to actively exercise in real time. When a human crew commits to a trajectory toward the ice giant Neptune and fires their primary engines to break away from Earth's gravity, they are crossing a line of absolute finality. There are no abort options waiting for them in the dark. There is no free return trajectory that can use simple orbital mechanics to gently swing their ship around the target world and slide them back home within a manageable timeframe. If a critical, non-fixable life support component undergoes a fatal failure in the third year of a 15-year outbound transit through the void, the entire collective wealth, political will and technological power of the planet Earth cannot save them. Even if the engineers back home could somehow miraculously launch a high-speed rescue vehicle the very next day, which is completely impossible, because no such vehicle exists, that rescue craft would still require over a decade of continuous travel just to reach the coordinates of the failing ship. The original crew would have been dead, frozen solid, and drifting through the vacuum for more than 10 years before any assistance could ever pull up alongside their hull. This terrifying operational reality is not a temporary design failure that can be engineered away with a bigger budget or a better rocket engine. It is an unyielding consequence of pure celestial physics and the immense, lopsided architecture of our solar neighbourhood. To fully understand the gravity of a crewed mission operating under these absolute constraints, we must look closely at the physical environment of our final destination. When a spacecraft finally completes its multi-year journey and enters orbit around Neptune, it does not arrive at a peaceful haven. It finds itself trapped in the gravitational grip of an ice giant that is surrounded by a highly unusual, chaotic family of moons. The structure of this local system provides undeniable proof of a violent, disruptive cosmic past. Unlike Jupiter and Saturn, which possess neat, orderly collections of major regular moons that all orbit in the same direction as their parent planet's rotation, Neptune's immediate neighbourhood is dominated by a single, massive, rule-breaking world that completely throws the entire system into permanent orbital disarray. This massive world is Triton, a moon that represents one of the most fascinating and terrifying destinations in the outer solar system. Triton accounts for more than 99.5% of all the mass currently orbiting Neptune, meaning that every other moon in the entire system is nothing more than a tiny, insignificant piece of rock compared to this icy giant. When Voyager 2 soared past Triton during its brief historic flyby, it revealed a surface that was completely unlike anything scientists had ever seen before. The moon is covered in a bizarre, wrinkled terrain that researchers quickly nicknamed cantaloupe terrain because its strange texture looks exactly like the bumpy, grooved skin of a melon. This landscape is a product of intense, ongoing geological activity driven by deep internal forces that continue to reshape the moon's frozen crust. The most shocking characteristic of Triton is its backward or retrograde orbit. Every other large moon in our solar system orbits its parent planet in a prograde direction, moving in the exact same direction that the planet itself spins. This orderly alignment happens because regular moons form out of the same spinning disk of gas and dust that created the parent planet in the first place. Triton, however, moves in the exact opposite direction of Neptune's rotation. This backward movement is absolute, definitive proof that Triton did not form around Neptune. It was born somewhere else entirely. As an independent dwarf planet floating freely within the crowded icy wilderness of the Kuiper Belt, right alongside worlds like Pluto. Long ago, Triton wandered a fraction of a degree too close to the massive gravitational well of the blue ice giant. As it attempted to coast past, Neptune's immense gravity reached out and snagged the travelling world, dragging it out of its independent orbit around the Sun and trapping it into a permanent chaotic embrace. This capture process was not a smooth or gentle transition. When Triton was first yanked into Neptune's family, its initial orbit would have been incredibly elongated, highly eccentric, and violently unstable. This chaotic orbit would have created immense, crushing tidal forces within the interior of the Moon, stretching and compressing its physical core over and over again with every single orbital pass. This intense gravitational kneading would have generated a massive amount of internal friction and heat, completely melting the entire interior of Triton and turning it into a global, sloshing ocean of liquid water and ammonia beneath a thin shell of ice. For hundreds of millions of years, Triton would have functioned as a violently active volcanic world, erupting with exotic icy lavas that flooded its surface and completely erased any ancient impact craters that existed before its capture. This explains why Triton possesses so few crater scars compared to other ancient moons like our own. Its surface has been thoroughly washed, remodelled and resurfaced by a long history of intense tidal heating. Eventually, over vast periods of time, this constant dissipation of tidal energy rounded out Triton's orbit, settling it into the nearly perfect circular path we observe today. But this circular path came at a devastating cost to the rest of Neptune's original native moons, as Triton's massive, backward-moving bulk repeatedly swept through the system during the chaotic capture phase. Its gravity would have acted like a cosmic wrecking ball. It would have violently destabilised the orbits of Neptune's original regular moons, flinging many of them directly into the crushing depths of the gas giant itself, or throwing them completely out of the system into the dark wilderness of interstellar space. The clean, empty gaps we see around Neptune today are the scars of an ancient orbital cleansing. For a human crew arriving at Triton, this backward orbit creates an incredibly complex and dangerous set of operational conditions. If you want to land a spacecraft on the surface of a normal prograde moon, you can use the parent planet's rotational speed to help match your velocities, making the transition into orbit relatively efficient. But because Triton is moving backward against the stream, any vehicle attempting to enter its orbit must perform a series of high-energy manoeuvres that require massive amounts of propellant. You're essentially trying to step onto a merry-go-round that is spinning at top speed in the opposite direction, a technical challenge where the slightest calculation error can result in a catastrophic high-speed collision. Once a ship successfully navigates these orbital hazards and touches down on the surface of Triton, the crew will find themselves standing on one of the absolute coldest places ever measured in the entire known universe. The ground beneath their landing pads is not made of rock or standard water ice. It is composed of a deeply frozen crust of solid nitrogen, methane, and carbon monoxide. The ambient temperature on this distant moon hovers around a staggering minus 235 degrees Celsius, which is only a few tens of degrees above absolute zero. At these extreme temperatures, the basic physical properties of everyday materials change completely. Metals become brittle as glass, shattering into tiny pieces under the slightest stress, and standard rubber seals snap like dry twigs, making vehicle maintenance an absolute nightmare. Despite this unimaginable frozen stillness, Triton is not a dead world. It possesses a thin, delicate atmosphere composed almost entirely of nitrogen gas, with tiny traces of methane near the surface. This atmosphere is incredibly faint, exerting a pressure that is only a tiny fraction of a percent of Earth's atmospheric pressure at sea level. Yet even this ultra-thin veil of gas is thick enough to support active, dynamic weather systems. When Voyager 2 swept past the Moon, its cameras captured stunning, undeniable images of massive geyser plumes erupting from the frozen ground, blasting columns of dark material and nitrogen gas miles into the sky. These nitrogen geysers are driven by a fascinating process known as a solid-state greenhouse effect. Triton's surface is covered by layers of relatively clear nitrogen ice. When the faint distant sunlight strikes these ice sheets, it passes directly through the transparent upper layers and strikes dark, organic material buried just beneath the surface. This dark material absorbs the solar energy and warms up slightly, heating the surrounding nitrogen ice from below until it sublimates directly into an expanding pocket of high-pressure nitrogen gas. Eventually, the pressure builds up to a critical point, violently ripping through the weak upper crust of ice and erupting into a towering column of gas and dark dust that can rise 5 miles into the thin sky before being swept sideways by the faint winds. For human explorers walking across this cantaloupe terrain, these active geysers represent a constant, unpredictable hazard. The ground beneath their boots could look perfectly solid, yet harbour high-pressure pockets of volatile gas just waiting for a structural disturbance to trigger a sudden explosion. Walking through this landscape would require constant vigilance, with suit sensors scanning the ice for subtle thermal anomalies or pressure changes. A single structural failure in an astronaut's pressure suit caused by an unexpected icy blast would result in instantaneous death, as the liquid water in their body would immediately boil away into the vacuum while their tissues froze solid within seconds. The visual experience of standing on Triton would be utterly surreal, defying any human sense of perspective. If you look up into the deep black sky, you are confronted by the immense looming presence of Neptune itself. Because Triton orbits relatively close to its parent planet, Neptune would appear enormous in the heavens, occupying an area of the sky that is many times larger than the full moon appears from Earth. It would hang there as a giant, permanent blue marble. Its complex bands of clouds and swirling storm systems moving slowly across your field of view. Because Triton is tidally locked to Neptune, the planet would never rise or set. It would remain permanently fixed in the exact same spot in the sky, a silent, watchful giant that dominates your entire existence. As you watch this giant blue world from the frozen surface of Triton, you are witnessing an environment that is slowly but surely moving toward its own ultimate destruction. Because Triton moves in a retrograde orbit, the subtle gravitational tidal interactions between the Moon and Neptune are slowly draining the Moon's orbital energy. Instead of being gradually pushed outward over time, the way our own Moon is slowly drifting away from Earth Triton is being pulled inexorably inward toward its parent planet. It is locked in a slow, tragic death spiral, creeping closer and closer to Neptune with every single orbit it completes. Planetary scientists calculate that in approximately 6 billion years, Triton will finally cross a critical threshold known as the Roche limit. This is the precise geographical boundary where the intense gravitational tidal forces exerted by Neptune will overcome the internal structural strength holding the Moon together. When Triton crosses this line, it will not simply crash into the planet as a single solid object. Instead, the entire Moon will be violently torn apart by Neptune's gravity, ripped into trillions of pieces of ice and rock that will spread out globally around the equator. This catastrophic destruction will instantly transform Neptune into a ringed planet that will completely rival, or even surpass, the beauty of Saturn. The shattered remains of Triton will flatten out into an incredibly dense, brilliant ring system that will circle the blue planet for millions of years. This realization introduces a profound sense of cosmic irony for any human crew exploring the Moon. They are standing on a doomed world, collecting scientific data from an environment that is mathematically destined to be ground into dust by the very giant that dominates their sky. They are walking on the ghost of a future ring system. To effectively analyse the full scope of a crewed habitat operating within this system, we must examine the broader family of natural satellites that share this space with Triton. Beyond that single captured giant, Neptune possesses a collection of much smaller inner moons that managed to form or survive after the chaotic reorganisation of the system. These tiny bodies, like Proteus, Larissa and Galatea, are completely different from Triton in every measurable way. They are dark, heavily cratered fragments of rock and ice that orbit very close to Neptune's upper cloud layers, moving in neat, circular prograde paths that match the planet's rotation. They look exactly like the ancient remnants of a broken generation, surviving in the narrow. Safe zones where Triton's massive gravitational broom could not completely sweep them away. Proteus, the second largest moon in the system, represents a fascinating structural limit in planetary science. It is an irregularly shaped, lumpy block of ice and rock that has a diameter of roughly 400 kilometres, making it just slightly too small for its own internal gravity to pull it into a clean, smooth sphere. It exists in a permanent state of structural tension, its surface completely saturated with massive impact scars and deep, jagged fractures that trace across its dark exterior. For an engineering team looking to establish an operational outpost or a secondary communications relay in the Neptune system, these small inner worlds present a highly distinct set of advantages and dangers compared to Triton. Because these inner moons orbit so close to Neptune, they are deeply embedded within the planet's complex magnetosphere and intense radiation belts. A human crew stationed on the surface of Proteus would be subjected to a continuous, punishing bombardment of high-energy charged particles trapped by Neptune's magnetic field. This local radiation environment is not as immediately lethal as the terrifying radiation fields surrounding Jupiter, but over extended operational timelines, it poses a severe cumulative threat to human health and electronic equipment. Any habitat built on these inner rocks would require extensive shielding, forcing explorers to tunnel deep into the dark. Frozen crust to use the moon's own icy soil as a natural barrier against the invisible energetic storm. Furthermore, navigating a spacecraft between these inner worlds requires a completely different approach to orbital mechanics than navigating around Triton. The inner moons are positioned so close together that their subtle gravitational interactions create a complex web of orbital resonances. These resonances actively shape and maintain Neptune's faint, dusty ring system, which consists of several distinct narrow arcs of material that shouldn't naturally exist. Standard orbital physics dictates that rings of fine dust should quickly spread out into a uniform, smooth sheet around a planet, yet Neptune's rings remain bunched up into tight, dense clumps known as the Liberty, Equality and Fraternity arc. This strange clustering is a direct result of the gravitational herding behaviour of the nearby moon Galatea. This tiny moon acts as a celestial sheepdog, its orbital position creating a localised gravitational trap that forces the drifting ring particles to stay bunched together in specific pockets of space. For an approaching spacecraft, these dusty ring arcs represent a subtle invisible minefield. Travelling through the inner system at high operational velocities means that a collision with a piece of ring dust no larger than a grain of sand can instantly punch a clean hole through a ship's fuel tanks or break its sensitive scientific instruments. The entire inner neighbourhood is a dynamic, tightly wound machine where every moon, ring arc and dust particle is locked in a fast, interconnected dance. Living and working in this environment would force a human crew to confront the absolute limits of sensory isolation on a daily basis. When looking out from an outpost on an inner moon like Larissa, the sheer scale of Neptune would completely dominate the human conscious experience. The blue planet would fill the entire horizon, stretching out as an immense, swirling wall of azure gas that exhibits no fixed solid surface, no landmarks, and no familiar features. The crew would watch massive white methane storm clouds materialize from nothing, stretch out across thousands of miles of the upper atmosphere, and then violently dissolve back into the blue depths over the span of a few orbits. It is a view of pure, unceasing energy on a scale that makes human architecture look utterly insignificant. This permanent visual confrontation with a giant indifferent world creates a unique psychological phenomenon that behavioural researchers call cosmic vertigo. On Earth, our sense of scale is comfortably anchored by small things, buildings, trees, mountains, and a clear horizon that feels reachable. Even on the Moon or Mars, an explorer stands on a solid rocky ground that extends predictably out to a visible horizon. But in orbit around an ice giant, your entire frame of reference is replaced by an abyss. You are looking down at a world that is 4 times wider than Earth, yet contains no soil to step on, no rocks to climb, and no solid foundation. It is a ball of superheated, high-pressure fluid wrapped in screaming winds, a place where gravity is immensely powerful yet offers nothing to hold on to. This realization would deeply affect the internal dynamics of the isolated crew. Human psychology is built on the concept of boundaries, of knowing where a safe space ends and where a hostile space begins. Inside the metal walls of the habitat module, everything is tightly controlled, measured, and familiar. The air is kept at exactly 1% oxygen. The temperature is maintained at a comfortable 22 degrees Celsius, and the artificial lighting mimics the natural 24-hour cycle of a terrestrial day. But just a few millimeters of aluminum shielding away, separated by a vacuum, hangs a giant blue world of absolute chaos and an endless expanse of freezing empty space. The contrast is so sharp, so violent, that it requires an enormous, continuous expenditure of mental energy just to maintain a sense of balance and focus. To sustain this internal balance over years of operation, the ship's environmental control systems must achieve a level of circular efficiency that has never been tested in the history of industrial engineering. Every single resource must be locked into an absolute closed loop where waste is a completely forgotten concept. In standard terrestrial life, we are accustomed to a linear consumption model. We take water from a well, use it and discard it. We grow food, eat it, and throw away the scraps. We burn fuel and let the exhaust drift away into the massive reservoir of the atmosphere. On a mission to Neptune, this linear model is an absolute death sentence. The ship is a completely sealed world, a microscopic island of life carrying a finite, unchangeable allotment of matter across billions of miles of nothingness. Consider the absolute complexity of the water reclamation infrastructure required for this voyage. Every single gram of moisture that enters the spacecraft must be tracked, captured, purified, and reused with a total efficiency rating of 100%. This means that the moisture exhaled by the crew's lungs during sleep, the sweat generated during mandatory daily exercise sessions, the grey water running out of the hygiene stations, and the raw sewage collected by the waste systems must be continuously rotated through a series of multi-stage distillation units, advanced chemical scrubbers, and high-pressure filtration membranes. The water an astronaut drinks with their breakfast meal is the exact same water that was running through the waste lines the previous afternoon, processed so thoroughly that it is chemically purer than any natural mountain stream on Earth. This continuous recycling process is not just a triumph of chemical engineering, it is an intimate, inescapable reminder of the crew's absolute physical interdependence. They are quite literally breathing each other's air and drinking each other's sweat, bound together in a shared biological cycle that cannot be broken for a single day. If a specialised biological contaminant or a resilient strain of mould somehow manages to breach the filtration loops and enter the water supply, it will quickly circulate through the entire ship, infecting every single crew member simultaneously. There are no external water sources to draw from, no fresh supplies waiting to be unsealed, and no clean reservoirs to flush out the system. The loop is absolute, and any failure in its purity means a swift systemic breakdown of the entire human component of the mission. The exact same unyielding rules apply to the spacecraft's atmospheric scrubbers. Human beings are constantly producing carbon dioxide, a gas that becomes toxic and eventually fatal if its concentration in the cabin air rises by even a few percentage points. On short-duration space missions, space agencies have traditionally relied on disposable chemical canisters filled with lithium hydroxide to bind and remove this waste gas from the air. But for a multi-decade journey to the outermost planet, carrying thousands of heavy single-use chemical canisters is completely out of the question due to strict weight limits. The ship must utilise advanced regenerative thermal scrubbers that use cyclic molecular sieves to continuously trap carbon dioxide molecules, bake them at high temperatures to release the gas, and then use advanced chemical reactions to break the carbon dioxide apart, recovering the vital oxygen while discarding the solid carbon. This process, known as the Sabatier reaction, combines carbon dioxide with hydrogen at elevated temperatures and pressures over a nickel catalyst to produce water and methane gas. The recovered water is then immediately routed to electrolysis units, where a powerful electrical current rips the water molecules apart into pure oxygen gas for the crew to breathe and hydrogen gas to feed back into the chemical reactor. The methane gas generated by this process is typically vented out into the vacuum of space, carrying away a tiny, unavoidable fraction of the ship's original hydrogen supply over a journey lasting 20 years. These microscopic daily losses of elemental hydrogen add up to a significant logistical deficit, a slow, unceasing leak of core mass that must be carefully accounted for in the initial launch calculations by packing large, heavy reserves of water or liquid hydrogen at the very start of the project. To fully capture the ultimate reality of reaching this outer boundary, we must look beyond the immediate machinery of survival and focus entirely on the profound psychological displacement that occurs when a human mind is severed from its home planet for multiple decades, when a ship settles into its permanent operational orbit around Neptune. The physical scale of the journey transforms from an abstract navigation calculation into a crushing daily emotional reality. Every explorer who has ever lived throughout the long history of human expansion has always operated with a fundamental psychological safety net, the absolute knowledge that they were still sharing the exact same present moment with the people they left behind. Even when sailing ships took years to cross Earth's vast oceans, or when polar teams spent months trapped in the pitch-black Antarctic night, they could look up into the night sky and find a direct, comforting visual anchor to home. A sailor lost on the trackless open ocean could watch the very same sun rise over the horizon that had shone down upon their family's home just a few hours earlier. An early 20th century researcher freezing in an isolated polar outpost could stare at the familiar face of the moon, knowing with complete certainty that the exact same light was washing over the roof of the house where their children were sleeping. Even the Apollo astronauts, who pushed human travel further into the vacuum than anyone else in history, could look out their cabin windows and see Earth hanging there in the deep black sky as an enormous, luminous, breathtakingly beautiful blue marble. It was close enough that the familiar shapes of continents were clearly visible to the naked eye, close enough that a lonely pilot could point directly to a tiny patch of swirling white clouds and know that their family was safe beneath that protective atmospheric veil. But for a human crew arriving at Neptune, this ancient psychological lifeline is completely and permanently severed. When they look out through the thick radiation windows of their habitat module, Earth is nowhere to be found. It has completely disappeared from the sky, shrinking down so far that it has fallen far beneath the natural resolving power of human eyes. The sun itself, the great blazing engine that drives all terrestrial life and defines our sense of time, has been reduced to a tiny, intensely bright needlepoint of light, a mere star that is only marginally brighter than the surrounding constellations. The stars themselves look ill familiar, has been completely removed. The crew must inhabit a cold alien sky that looks almost identical to the one they left behind, minus the one single planetary object that gave their lives meaning and context. This total visual disappearance is not a minor psychological footnote. It is a profound structural trauma to the human consciousness. Extensive behavioural research conducted by space agencies has consistently shown that the simple act of Earth observation of looking down at our home planet through a spacecraft window is one of the most powerful restorative countermeasures against the psychological decay caused by extreme isolation and confinement. Astronauts living aboard the International Space Station describe the experience of watching Earth as an essential, deeply moving daily ritual that actively heals their minds after long hours of stressful technical work. The sight of blue oceans, swirling white cloud patterns, rich green continents, and the incredibly thin, bright line of the protective atmosphere reminds an isolated worker at a visceral, subconscious level that the vibrant world they belong to is right there, just a few hundred miles below them, eagerly waiting for their return. Many space travellers have reported that photographing Earth is their absolute most valued recreational activity, a beautiful practice that simultaneously fights off the crushing monotony of life inside a metal container, reinforces their deep emotional connection to home, and generates that profound perspective shift that psychologists formally call the overview effect. But at Neptune, the overview effect does not exist. There is absolutely no Earth to photograph through the viewport. There is no warm home waiting down below. There is only a deep blue, indifferent ice giant, a captured moon erupting with freezing nitrogen geysers, and a sun that has lost its warmth. The most disorienting aspect of this physical separation is the absolute breakdown of shared time caused by the communication delay. On any space station operating in low Earth orbit, when an astronaut sends a voice or video message to their family, the signal travels at the speed of light and arrives almost instantaneously. The ensuing conversation exists in a shared present tense, where both individuals inhabit the exact same moment in time, responding immediately to the subtle shifts in tone, laughter, or emotion that define true human connection. But at Neptune, the crew exists in a completely different temporal reality than the entire human species, because light requires over 4 hours to cross the multi-billion mile chasm between the two worlds. Any message sent from the spacecraft is already a dispatch from the ancient past by the time it finally reaches a receiver on Earth. The reply sent back across the void is equally a dispatch from the past by the time it travels all the way back to Neptune. Nothing is simultaneous, nothing is current. every single interaction is fundamentally delayed, outdated and stale. A crew member's child could be born in a terrestrial hospital, and the parents stationed at Neptune would not learn of the birth for more than 4 long hours. Their immediate, emotional, congratulatory reply would then take another 4 hours to travel back through the dark emptiness of space. The child would be nearly a full standard workday old before a single, simple exchange of words had actually occurred. A crew member's aging parent could pass away, and the tragic news would travel silently through the solar void for 4 hours before reaching the grieving child inside the habitat. Their immediate tears, their desperate words of remembrance, and their fundamental human need for comfort would radiate outward from Neptune at the absolute speed limit of physics, only to arrive at a world where the funeral has already completely concluded, where the other mourners have already packed up and gone home, and where the peak moment of shared family grief has long since passed without them. These are not far-fetched hypothetical scenarios. These are the deeply heavy, life-altering milestones that naturally and inevitably occur over the course of decades of human life. A crewed mission to Neptune, requiring a minimum of 12 to 20 years for a one-way transit under any realistic propulsion technology, would completely encompass births, deaths, marriages, divorces, sudden illnesses, unexpected recoveries, political elections, major wars, devastating natural disasters, and grand technological revolutions. The isolated crew would experience every single one of these historic changes on an unyielding 8-hour delay. They would learn about the profound transformations of the civilization they left behind only after those transformations had already stabilized into cold historical facts. They would find themselves responding to joys and sorrows that had already faded into distant memories for the people who actually experienced them. Over months and years of this continuous temporal dislocation, Earth would undergo a radical transformation in the crew's inner psychological landscape. It would gradually cease to function as a real place that exists actively in the present moment, and would slowly transform into an abstract concept that exists exclusively in the past tense. Every single incoming transmission from home would arrive stamped with a permanent reminder of its own obsolescence, a lingering whisper that says, "This happened 4 hours ago." Every outgoing response from the crew would be sent with the exact same tragic disclaimer. The two distinct worlds, the microscopic human island orbiting Neptune and the massive, bustling civilization back on Earth, would drift apart not just across physical distance, but temporally, emotionally, and experientially. The crew would certainly still understand intellectually that Earth exists out there in the dark. They could still regularly receive news packages, scientific data updates, and digital entertainment packages transmitted across the solar system by powerful deep space antennas. But the Earth they receive would always be an old Earth, a historical Earth, a world that has already completely moved on from the very moment being described in the data stream. This is the true, terrifying meaning of 4 hours of silence. It is not merely that communication is frustratingly slow, it is that the shared human present has been permanently shattered. This temporal displacement deepens dramatically when we calculate the total duration of the mission across a human lifespan. A realistic voyage to Neptune is not a quick expedition, it is a generational commitment. If a highly trained astronaut departs Earth orbit at the peak of their career, say at 32 years of age, the outbound journey alone will consume 12 to 20 years of their life. While they are hurtling through the outer darkness, they are aging, but so is every single person they left behind on the home planet. Their young children are growing up completely in their absence. Their romantic partners are navigating middle age alone, and their elderly parents are growing frail and dying in distant hospitals. The complex social fabric of the astronaut's former life their friendships, their professional networks, and the shared daily context that defines an individual's identity slowly erodes and transforms with every passing year. After 5 years of transit, the crew's friends have bought new homes, changed careers, and formed entirely new social circles with people who have never even met the far-flung explorers. After 10 years, the crew's children have transitioned into full adulthood, having lived more than half of their conscious lives without ever having a parent physically present in the room. After 15 years of continuous travel, the world the crew originally left behind has become an entirely different planet, not just metaphorically, but literally, culturally, politically, and technologically. A decade and a half of unceasing human civilization on Earth produces structural shifts so deep that a person who departed in one distinct cultural era would return to find themselves completely out of place. Except at Neptune, they do not turn around and return. If a return trip is mathematically possible within the mission architecture, that homeward journey will consume another 12 to 20 years of travel through the void. This means the total period of physical separation stretches out to a staggering quarter century, 30 years or even longer. The astronaut who originally stepped off the planet at age 32 would finally return to Earth as a 60 or 65-year-old individual, walking back into a world that has evolved entirely beyond their recognition, and that contains almost no one who remembers them as they actually were. Their children are now middle-aged adults with their own families. Their grandchildren are complete strangers who only know them as a historical name, and the very language spoken on the streets may have shifted in subtle modern ways that make the returning crew feel like ancient visitors from a forgotten era. This is the true, ultimate meaning of leaving behind everything that makes human life feel human. The biology travels with you inside the life support loops, your cells continue to divide, your muscles require exercise, and your brain continues to process thoughts. The intelligence travels with you, you bring your technical knowledge, your scientific curiosity, and your analytical mind wherever you go. What you permanently leave behind on the launch pad is the intricate, invisible web of immediate connection, shared time, and mutual physical presence that allows a conscious human being to feel that they truly belong to something larger than their own skin. At Neptune, that beautiful web is completely gone, and what remains is the most profound, absolute solitude the universe has ever offered to a conscious mind. Reaching the 8th planet does not mean entering a new world. It means stepping off the edge of human belonging entirely.